Empty set. A set which does not contain any element is called the empty set or the null set or the void set, and is denoted by this phi or this empty set. This empty, just we have to make the curly bracket and keep it blank. So that is empty set. So let us see some examples of empty set. First one, let A equal to collection of all x such that x is an natural number between 1 and 2. So we know that there is no natural number between 1 and 2, so there will be no elements. In this case, the set A will be an empty set. Another one, second example, B equal to collection of all x such that x square minus 2 equal to 0 and x is a rational number. Now if we solve this, we will get x square equal to 2 and x will be plus minus root 2. So x cannot be a rational number, x will be irrational. So there will be no element in the set B, so it will be an empty set. Similarly, let us see the third example. C equal to collection of all x such that x is an even number greater than 2, even prime number greater than 2, and we know that there is only one prime number which is even, that is 2, and all other prime numbers are odd, and therefore there cannot be any even prime number greater than 2, so the set will be empty. Fourth part, D equal to collection of all x such that x square equal to 4 where x is odd. If x is odd, then the square of x cannot be even, but here x square equal to 4, therefore there will be no element in the set C, and therefore it will be an empty set. Next, finite and infinite sets. A set in which you can count the number of elements, or if it is an empty set, it is known as finite set. If you cannot count the number of elements in a set, then it is known as infinite set. So here we can see there are three examples: A equal to 1, 2, 3, 4, 5, B equal to A, B, C, D, E, G, and C equal to men living presently in different parts of the world. So present means at a particular time. So this also can be counted. The number of people living in the world can be counted. Suppose a particular time is given, at a particular time how many people are there in the world, that can be counted. So all these three are finite sets. So here definition number 2, we are having a set which is empty or consists of a definite number of elements is called finite set, otherwise it is called infinite set. So now here in set A there are 5 elements, so we write it like this: Na equal to, Na stands for number of elements in set A. So how many are there? 5. Now B equal to A, B, C, D, E, G. How many elements are there? There are 4, 1, 2, 3, 4, 5, 6. There are 6 elements. We write it as NB equal to 6. So NB stands for number of elements in the set B. Now let's go further in this. So equal sets. What do we mean by equal sets? Equal sets, two sets A and B are said to be equal if they have exactly the same elements, and we write it as A equal to B. Otherwise the sets are said to be unequal, and we write A is not equal to B. So if two sets are having the same elements, order may be different, same elements should be there, then they are said to be equal sets. Otherwise they are said to be unequal sets, and we write in that case, if they are equal, we write A equal to B. If they are not equal, we write A is not equal to B. So next we will go in exercise 1.2. Exercise 1.2, question number 1. Which of the following are examples of the null set? First one we can see, set of odd natural numbers divisible by 2. So exercise 1.2, question number 1, first part. Now we know that what do we mean by natural number? Odd natural numbers. Odd natural numbers are those numbers which are not divisible by 2. Odd natural numbers are those numbers which are not divisible by 2, are those numbers which are not divisible by 2. And here what we have to find is, we have to find a set of odd natural numbers which is divisible by 2. Therefore such a set is not possible. Therefore such a set is not possible. Such a set is not possible. Such a set is not possible. Therefore the set will be an empty set. Therefore, the required set will be an empty set. The required set, therefore, the required set will be an empty set. Will be an empty set. So the first one, question number one, first part is an empty set. Now second part, set of even prime numbers. Now even prime numbers, how many even prime numbers are there? There is only one even prime number, that is 2. So that means their set is not empty. There is one element containing that. So it is not in a null set. So second one is not a null set, not a null set. First one is an empty set. Then third part, x said that x is a natural number and x is less than 5 and x is greater than 7. So we have to find a natural number which is at the same time smaller than 5 and since it means together should be smaller than 5 also and should be greater than 7 also. So it is not possible. So it will be a null set because we cannot find a natural number which is less than 5 and greater than 7 at the same time. So it will be null set. Then fourth part, y, fourth one, collection of all y such that y is a point common to any two parallel lines. We know that parallel lines are those lines which have no point in common. So this will be also null set. Now question number 2. Which of the following sets are finite or infinite? The set of months of a year. Since we can count the number of months of a year, so this will be finite set. Now the next one, here we are having this set 1, 2, 3. This is a set of natural numbers. Dot 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 means that the elements are going on, and we do not know which is the last natural number. It goes on. So this is infinite set. Infinite set. Then third one, this is set of natural numbers which is less than 101. So how many natural numbers are there? 100. So this is finite because we can count the number of elements. Finite set. Then fourth part, the set of positive integers greater than 100. Greater than 100, the integer can be as big as possible. So this is also infinite. You cannot say that this is the last uh, number which is greater than 100. Every time if you add 1 in that, it will be bigger than the earlier number. So this is infinite set. The set of prime numbers less than 99. Since uh, the number of prime numbers less than 99 can be counted, so this will be finite set. Now let us go in third one, question number 3. State whether each of the following set is finite or infinite. The set of lines which are parallel to the x-axis. We can draw infinite lines parallel to x-axis, so this will be infinite. Then second one, the set of letters in the English alphabet. We know how many English alphabet letters are there. There are only 26 letters which are in the English alphabet. So it is countable, and so it will be, the set will be finite. The set of numbers which are multiple of 5. There are infinite multiples of 5. So this is infinite set. Now fourth part, the set of animals living on the earth. So this is also finite because we can count the number of, at any given instant we can count the number of elements. So this is finite set, number of animals living on the earth. Then fifth part, the circle passing through the origin 0, 0. We know that from our study of class 9 also we have seen that through one point infinite circles can pass. So this is infinite set. Then let us go in fourth one, question number 4. In the following state whether A equal to B or not. We know already, we have seen the concept of equal sets. Equal sets are those sets which have the same elements, order may be different. So question number 4, first part, A equal to the set is ABCD, B equal to the set is DCBA. Elements are same, only orders different. So this is, so here we can say that A equal to B. Second part, A equal to 4, 8, 12, 16. The elements are 4, 8, 12, 16. And here the elements are 8, 4, 16 and 18. If you see that in these two sets, this 18 is present in set B, but it is not present in the first set A. Similarly, in first set A, we are having 12. 12 is in first set A, but it is not in set B. Therefore, we can say that the two sets are not equal. So, A is not equal to B. So, what you will write? You have to write that since 12 belongs to A, but 12 does not belongs to B. Therefore, A is not equal to B. So, here I will write the way it is to be written. Question number fourth one, second part. Since 12 belongs to A, but 12 does not belongs to B. 12 does not belongs to B. Therefore, we can say that A is not equal to B. Therefore, A is not equal to B. Now, let us go to the next one. Third part, A equal to 2, 4, 6, 8, 10 and B equal to collection of all x's. X is a positive even integer and x is less than or equal to 10. So, what we have to do is we have to write B in tabular form. So, we will be doing now third part, question number. So, third part we are having here A equal to 2, 4, 6, 8, 10. 2, 4, 6, 8, 10 and B equal to collection of all x such that x is a positive even integer and x is less than or equal to 10. So, it is an even integer and it has to be less than or equal to 10. So, the first even integer, positive even integer, not only even integer, it should be positive even integer. So, first is 2, then 4, 6, 8, 10 and we can see that the elements of A and B are identical, they are the same. Therefore, A equal to B. Now, let us go in the next one. Question number 5, fifth one. Are the following pairs of sets equal? Give regions. So, first question number 5, first part. A is equal to 2, 3. B equal to x so that x is a solution of x square plus 5x plus 6 equal to 0. So, B equal to, let us solve x square plus 5x plus 6 equal to 0. So, this we can write as x square plus 2x plus 3x splitting the middle term plus 6 equal to 0. So, this will give us therefore x into x plus 2 plus 3 into x plus 2 equal to 0. Therefore, x plus 2 into x plus 3 equal to 0. So, this will give us x equal to minus 2 or minus 3. So, B is minus 2 minus 3. B equal to minus 2 or minus 3. Therefore, we can say that therefore we can say that A is not equal to, this is equal to, cancel it. So, this will become A is not equal to B. So, the sets are not equal sets. Then let us go in second part. So, in second part, A is collection of all x such that x is a letter in the word F, L, F, O, double L, O, W. So, the letters will be F, then O, then L and then W. In B, the letters will be W, O, L, F. So, they are the same. That means A and B are equal sets. Then let us go in question number 6 one. From the sets given, select equal sets. So, here we have to select the equal sets. So, A is 2, 4, 8, 12. If you see it here, 2, 4, 8, 12, 2, 4, 8, 12. So, there is no set which is equal to set A. B is question number 6 one. B is 1, 2, 3, 4 and D is also, the elements are same 1, 2, 3, 4. So that means B is equal to D. B equal to D. Then for C, in C there are 4 elements, 4, 8, 12, 14, and there is no other set which is equal to C. So there is also no other set equal to C. Then let us go for, we have already seen this D and A, we have compared it, and now let us go for E. E is having two sets, two elements minus 1 and 1. G is also having the same elements minus 1 and 1. So that means E is equal to G. E equal to G. Then F elements are 0 and A. There is no other set having the elements as 0 and A. And H elements are 0 and 1. Also there is no other set which is having the elements as 0 and 1. So only two sets are there which are equal sets, that is B is equal to D and E is equal to G.